Before jumping into the podcast, I wanted to point out a place near the end of the show where our guest, Jan, talks a bit about a panel that we'll be doing together on the following week. This podcast actually was recorded before we actually edited it and published it after the event. However, you can still hear that panel by heading over to live.infoq.com to find out more information on it, and also on upcoming live.infoq.com events. These events are full-day events around a topic in software, and they feature short talks from people like Adrian Cockcroft, but they also feature a peer-sharing component that connects attendees in a more personal way. So head over to live.infoq.com to find out more about the panel that Jan talked about and about future events that are coming up. Thanks for listening today. Hello and welcome to the InfoQ Podcast. My name is Wes Reisz. I'm the co-host of the podcast and chair of QCon San Francisco. Today on the podcast, I'm speaking with Yan Choi. Yan will be talking about serverless. Specifically, we'll be talking about things like the difference between orchestration and choreography when it comes to serverless. We'll talk a bit about distributed tracing in the context of serverless applications. And then we'll talk about this new approach that Amazon offers with mounting larger files from EFS to be able to deal with kind of large file sets. Yan Choi is an AWS serverless hero. He has worked with AWS technology since 2009. Today, he's an independent consultant. He has been in roles that are around architecture, lead developer, and he's an advocate in industries ranging from banking to mobile games. He blogs at theburningmonk.com, and you can find his talks on serverless all over the web. Jan, welcome to the show.
Hey, thanks for having me.
So this podcast kind of comes back from a blog post that I read on you that's up right now, at least, that's around choreography versus orchestration. So I wanted to kind of just dive in and talk about this when it relates to serverless. So I guess let's just start off the very beginning. When we talk about serverless and we talk about choreography, what does that mean?
Yeah, so I guess when I'm building applications using serverless technologies, personally, I'm still thinking in terms of building microservices, in terms of thinking about bounded context, in terms of thinking about how different microservices communicate to each other. And choreography and orchestration are the two ways that microservices typically communicate with each other. So where you're talking about choreography, this is whereby you're probably talking about event-driven architectures, whereby services don't talk to each other directly in the sort of normal, or at least the traditional request response model, whereby receiving an event, I do my thing, and then I publish an event when I make some state change, and then that's it. I'm just doing my part. I know what my events are. I know what I should do when those events happen, and I know what event I should emit when I do something interesting. And everybody just do that. And then you get the system behaving in a certain way based on how all the different components react to events and what they do and what events they emit. So this is a really nice way for you to build really decoupled, loosely coupled systems using lots of different components that just looking after its own bit. And then you have orchestration, whereby you have essentially some kind of a controller component that says, okay, when something happened, when there's a request comes in, you do something first, and then you do something else. And then if the state of the system is in some state, you should do something. Otherwise, maybe we skip you and we get someone else to do something else. So you have that centralized controller component, and that is what we call a orchestration model. So in the sort of serverless world, given the fact that when you're talking about Lambda and lots of other services, they're inherently event-driven. So I think this choreography model has been very, very popular when it comes to building serverless applications. You see a lot of people building very complicated systems using Lambda and other queues that you have in the system in AWS, like SNS, SQS, EventBridge, Kinesis, and so on and so forth. But I think there's still a lot of places where you should be thinking about using orchestration instead, using some service like step functions where you can model the entire workflow, and that can be source controlled and use that to trigger different bits of compute or Lambda functions you have.
So let's break it down a little bit more. So with choreography, you might have something like a Kinesis stream and you have events flowing through it. And then you would basically register your serverless function to react to different events that come through. Is that right?
That's right. And then once you say you've written an order into the database, you will also publish an event to say order has been confirmed, the order has been placed, so that maybe some other system can listen to that particular event and maybe you want to implement some kind of a promo code, for example. You don't want that to be tied to the function that's saving the order, but you can have them loosely coupled and only depend on these shared contracts you have through this event.
What are some of the, I guess, smells with that approach that kind of lead you to the need for more of orchestration?
Yeah, so the great thing about choreography is that everything is loosely coupled. They can be scaled independently. They can be modified, deployed, and updated independently. You also don't have this a single point of failure from the point of view of, say, an organization. If one person mess up the promo code system, it's not going to affect all the processing and so on and so forth. The downside of this approach is that now you don't really have a way to easily monitor and report on the end-to-end progress or status of, say, an order. If, say, for example, you have for all the processing, you have multiple steps. Every single step is implemented as a separate Lambda function that just listens to some event, does its thing, and then saves some other event that triggers the next bit. So when you have, say, something like all the workflow implemented using this choreography approach, means things like even something simple like, oh, we should have a timeout on the order so that if it's not completed process within 3 hours, we should just give up. I mean, the customer placed an order for dinner. If we're not delivering the food within 3 hours, then what's the point, right? So that kind of thing becomes quite difficult to implement, even though it's quite common and quite a simple requirement, really. And also, I guess when it comes to bigger companies and you have more complex workflows, it also becomes quite difficult to pin down on who is a person or team that's got the entire knowledge about how the system works end to end. You've probably been in situations whereby something's gone wrong. You go to a war room with all these different teams and you're trying to find out, okay, guys, what actually went wrong? What happened? Nobody knows because everyone just knows their tiny bit, but no one's got a complete picture of how everything works. And of course, how the system behaves is not captured in code. Not really. It's the emerging property of how your event-driven system is all doing its own bit. How the system behaves end to end is just an emergent property of that. How the workflow actually works is not the source controlled. So I think that's where you have business logic that's spread across many different places and probably across many different teams and different brains. So you open yourself up to all kinds of problems with that. And some people maybe leave the team and you lose those knowledge about how the system actually works. I've seen lots of companies rebuild entire systems because people that knew the system left the company and the documentations are out of date, doesn't reflect how the world actually is right now. Whereas with the orchestration approach, where you're using some kind of a workflow engine like step functions, your actual workflow itself is source controlled. It's not just documentation, it's the actual executable. So I think for something like processing orders or payments or things like that, I think the orchestration approach makes a lot more sense, especially when you're talking about something that's business critical and you get all of this end-to-end reporting as well as monitoring out of the box with step functions as well.
So with orchestration, it's kind of like a state engine, right? You can model the behavior of the system and then maintain that state with your orchestration engine. Is that accurate?
Yes. So with the step functions, I don't know if you've seen it before, you've got this modeling language that's based on JSON or YAML, but then you also have the execution engine whereby at runtime, you will trigger Lambda functions and you keep the state of your application. And there's a visualization tool as well, where you can see for a particular execution, where did it end up or where is it currently? And you can see the state at each step of the workflow as well. And then there's also all the history and all the different things. And you can also implement things like a timeout or for a particular step or for the entire workflow itself. Those things becomes really trivial for you to implement. And one of the great things I love about using workflow engines like this, especially when dealing with something that's more, complicated, is I can show that workflow visualization to a business analyst or someone who is non-technical, and they can figure out, roughly what this thing does. And even for your support team who otherwise will have to troll through logs and try and ask people, okay, what does this mean when I see this log message? For something like step functions, they can just go into the console, look at the visualization for customer's request, and they can figure out, okay, right, so your payment failed because when we tried to verify your card number with MasterCard, it came back with so-and-so error.
So is a step function a silver bullet? Should we just use step functions for everything?
No, so it's great for modeling and implementing business workflows, especially business critical ones. But there's still a lot of places where you should be using choreography instead, especially when you want to, for example, take all the processing example I'm using. If someone want to build the promo code example that I mentioned earlier, well, we don't want to have everything that have to do with an order have to be implemented inside this same workflow. Instead, we should still be using events so that inside our workflow, if we are, say, save the order in a database, or we change the status of the order, or we maybe communicated with MasterCard to confirm the payment card detail, when some state changes happen, we can still emit events from inside the workflow, and then we can build on top of those events other microservices that looks after different aspects of the business, maybe different business workflows. So you should still be using choreography between these bounded contexts of microservices or whatever you like to call them, but within the microservice where you have, I guess, more control around one particular aspect of the business. At least when it comes to workflows, you should be using something like step functions, some kind of workflow engine that lets you have that orchestration.
So you keep the logic within the bounded context just as a microservice kind of dictates. Makes sense. So a lot of the vocabulary that you're using, step functions, is very AWS centric. What about other cloud providers like, Azure and Google Cloud Functions? Are the constructs the same there?
I think most of them have something similar. So I know with Azure, you have Logic Apps, which is, I guess, the like for step functions in Azure. I'm not sure what's the equivalent in GCP. I think that's like a workflow thing. I forgot the name of that service, but I do remember seeing it before.
What about third-party or non-cloud provider provided tooling?
You have lots of other open source tools as well as other third-party services. Camunda is quite a nice one as well. I think you can use it as a service that you can run yourself, or you can, I think they've launched the cloud service recently, a couple of months ago, if I remember correctly. So there's quite a few other alternatives that you can use. So if you're running your own infrastructure on top of containers or whatnot, then you maybe want to use some of these open source tools that where you can have a workflow engine running on top of Kubernetes or on your own containerized environment.
What I'm hearing you then saying, kind of the big takeaway, is that you should prefer orchestration when you're within the bounded context of a microservice, but choreography between it to allow the units to be able to interact, I guess, loosely.
Yes, I guess that's just a general rule. That's kind of what I tend to do. At least when it comes to business workflows, there are loads of other small places where I'll still use events, but not use it to implement some kind of a workflow. So for example, within my microservice, I may still use things like S3 and use that to trigger Lambda functions or putting stuff into Kinesis so that I don't process something right away, or use things like EventBridge to trigger one-off things, but not complex or not business critical workflows. So for those, I'll definitely try to prefer the orchestration approach instead.
So I want to switch gears just a little bit and talk about another kind of challenge, I guess, when it comes to serverless, and that's distributed tracing. It's been a while since I've dove into serverless in this space. So what is today's state of the art? What's the AWS story? What does it look like for distributed tracing when it comes to serverless architectures?
It's gotten a lot better. So interesting that you mentioned distributed tracing, because that is one of the difficulties when it comes to a really event-driven architecture on AWS with Lambda, that a lot of tools have to support a lot of things that it just never had to do before. Before, it was so HTTP requests here and everywhere. It's kind of easy to trace those. We know how to do that. But now we're talking about event-driven architecture of Lambda, and you have to trace invocations through lots of different things like SNS, SQS, Kinesis, DynamoDB streams, IoT core, messages, hubs. There's just lots of different ways you can trigger one function and then another. So in terms of the tools out of the box, you have X-Ray. It supports those synchronous HTTP invocations really well. So you've got one Lambda function calling another through, say, API gateway or direct invocation. You can see those no problem at all. There's still some work you got to do yourself in terms of requiring the AWS X-Ray SDK and then using that to wrap your AWS SDK or your HTTP modules. But in general, it works quite well for those kind of simpler architectures. But we find that a lot of people are now building really complicated, interesting architectures with Lambda because there's just so many different things you could do. And when there's so many things you could do, people do lots of different things. So in this space, you've got lots of, newcomers, more serverless focused vendors, people like Lumigo, who are actually, full disclosure, I spend 2 days a week working with those guys as a developer advocate. I have a really strong belief in their platform and what they're doing. And I think what they offer is probably the best user experience for third-party tracing system for serverless applications. But then you also have other things like Abscon and Thundra as well, whereby these third-party solutions, they can do a much better job of tracking invocations through asynchronous sources, such as SNS, such as SQS, Kinesis, and so on.
When we were talking, kind of prepping before this, you were talking about one of the most difficult things with serverless and distributed tracing is understanding the state of a system at any given point. Can you elaborate a bit more on that and kind of discuss that?
One of the most difficult things I find about dealing with these really expensive and really interesting and sophisticated architectures is that trying to understand the state of a system at every moment in time. You're talking about, when your function calls another function, publish an event through EventBridge, triggers another function somewhere else. Well, what was the state of that Lambda function? And you make the call to DynamDB and that returns an error. And then you can trace it back because, the second function or third function called DynamDB with the wrong parameter. And that parameter came from the event it got, which came from the first function that published some wrong data to the event bridge that triggered a second function, passed the bucket on to the next guy, right? So trying to trace through those kind of problems is quite interesting and quite difficult sometimes without the right tools. And that's where something like Lumigo, I think, is really useful because they show you both your architecture in terms of, here's a Lambda function, publish something to SNS topic that triggers another Lambda function and so on. But all the logs for those 3 Lambda functions that's part of the transaction side by side. And you can, when you click on one of those Lambda functions, you can also see the input you got as an invocation event and where that function talks to other services like DynamDB. You can also tap on the DynamDB icon and see what request was sent to DynamDB. So using that, I'm actually able to walk through how that piece of data, how that request that I'm sending to DynamDB came to be in the third function in my transaction.
Is the premise still the same where, you come in, you get a correlation ID, and that correlation ID is passed all the way through each of the functions so that you can recreate the trace for that particular request? Is still the same premise, or does it operate kind of a little bit differently?
It's still the same premise. Some of the implementation or under the hood, they're using correlation IDs still. But in addition to just correlation IDs, they also record states about your invocation, things like the invocation event, and they also auto-trace every single request you make to other AWS services or other HTTP endpoints so that you can see what other things your function has spoken to, so that you get that auto instrumentation out of the box without you having to manually write logs, put the correlation IDs in and say, I'm talking to so-and-so HTTP API, or I'm writing something to DynamDB. And then afterwards you realize, I'm missing something. I need to go back and write another log file.
So how does it, in a longer transaction that has multiple participants of a serverless function, how do you deal with just like knowing the time it takes a request to respond, that whole kind of holistic view of that request?
So that's where a lot of tracing systems also helps. But if you just care about that one number, the end-to-end number, then you can look at the duration for that edge-most function. So that will tell you the end-to-end, provided that you're talking about synchronous calls, one function calling another API, which is another function, calling another one, and so on. But for more sort of end-to-end event flows, that's where you do need something like X-Ray or Lumigo or something else that can track those asynchronous transactions. With X-Ray, the async support is not great. It only supports SNS. SQS is, you can see the event going to SQS, but then you don't see the next Lambda function invocation that picks up the message from SQS in the same transaction. So that's where some of the other third-party commercial tools can do a much better job in supporting those different event sources for Lambda and being able to connect everything together.
So my background is Java, and it's been a while since I've done any serverless functions, but there used to be some blind spot with cold start times and things like that. What's that state today? What does it look like, particularly when it comes to like tracing and cold start? What does that kind of look like today?
Also, it's been a lot better. So certainly for Java and for .NET Core, it's still a little bit rougher compared to some of the other language runtimes. So for Node.js and for Python and Go, I guess you can look at in the real world, cold start time somewhere around, 3 to 800 milliseconds is quite normal without much optimization. With Node.js functions, with a little bit of optimization, you can bring that down to probably 300 milliseconds or so. But for Java, you're probably still looking at around 500 to a second, probably be more closer to 1 second, even with some optimization work you're doing there. But in general, cold start has been getting better. AWS has done a lot of work behind the scenes to improve different aspects of cold starts. And also for Java functions, now your kind of get out jail card is to use what is called provision concurrency. Essentially, it's a way for you to say, well, I know my traffic is going to need 10 containers running most of the time. So rather than having to suffer cold starts because the system always scales to 0, I'm just going to pay you some extra to have 10 containers running all the time. But when I need more, let the normal on-demand scaling behavior kick in. So provision concurrency is kind of your get-out-jail-free card when it comes to Lambda and cold start, provided that you can't optimize your code anymore, or you have a lot of synchronous API calls between your Lambda functions, so that even if you do minimize the cold start for one function to say 500 milliseconds, and it's okay for your 99 percentile, but then when they stack up, when you got one function calling another, they start to stack up, and that's still not good. So that's where you want to use something like provision concurrency.
So a few years back, I remember I was working on an application that was serverless, and I kept running into file size limitations. AWS now has the ability where a Lambda function can mount another volume to it. Can you talk a little bit about what that looks like?
Yeah, so that is done through EFS, or the Elastic File System. Essentially, it's a network file drive that you can mount to your Lambda function, which does require your function to have VPC access to where you have configured the file system in the EFS. But it does mean that for a lot of people that used to have problem with loading large files, so if you're doing machine learning, you're using TensorFlow, the executable and the model are often 2 gig, maybe more, really, really big, and you can't load them into Lambda, even though you can have 3 gig of memory, you can only have 500 meg of disk space. So with EFS, that kind of works around that problem, whereby for those large files, you can put them onto EFS, and when your function starts up, you can then load them from the EFS.
What about issues with latency?
The latency on EFS from the testing I've done is a bit better than loading from S3, at least a bit more predictable. It's more stable, less variance, but it's still quite high. So if you've got a really large file, you're loading from like a 2 gig TensorFlow model, and you're loading it from EFS into a Lambda function, it will probably work, but it's probably going to take, tens of seconds for that to complete, maybe 20 seconds or 30 seconds, I don't know, which means that you do have to have a fairly long Lambda function duration to be able to work with them. So you can't do anything that's serving real-time recommendations from Lambda. But if you're just doing some training or testing your model, that's probably okay.
Or just inferencing with a model, maybe, and just running the actual decisions on it. Okay.
Yes.
So what's next for you? What are you working on?
So I've gone independent for the last 12 months now, 13 months maybe, where I still left full-time employment and now working for myself, working as an independent consultant and working with lots of different clients. And I have to say, it's been a really refreshing change. And I've worked full-time for 15 years. I have to say, this newfound freedom and also just being able to work less has been really great. I'm really loving it. So at the moment, I'm really enjoying working with lots of different companies, helping them build the serverless applications better, faster, and learning quite a lot as well. It's amazing how many different ways or different constraints people have to deal with and the different systems that people are building with serverless. So that's been a really fun the last year and a bit.
Well, Jan, as always, thank you for joining us, and I look forward to catching up with you real soon.
Yeah, hopefully, I guess I'll see you at the InfoQ Live.
That's right. So InfoQ Live, it will be on August 25th. So if you like what you heard and you want to hear more, Jan will be part of a panel with me hosting. We'll be talking about microservices, answering the question, are they still worth it? And I want to go on that limb and say yes. So Jan, I look forward to seeing you then. And thanks for joining us on the InfoQ Podcast.
See you next week, man. Bye-bye.